And what we realize that we usually refer to what is known as a probability distribution table. And from there, in some cases, a function may be given. In other cases, you have to, from the information given, you have to do your own thing. Okay, then from there we're gonna be looking at something different here. Okay, we're gonna be doing one more of these type before I give. We did this. What's it? Okay. Okay, it's saying here that the discrete random variable x can take the values 5, 6, 7, 8, and 9. The vertical line graph to illustrate the distribution of x is incomplete. Given that the probability of x is equals to 8 is twice the probability of x equals 9, complete the line graph and describe the distribution. Now, let's see. It tells you here that x take the value 5, 6, 7, 8, Okay, so this is the distribution table. Okay. Now, how would we go about doing this problem? Here we have the values for small x. So how would we determine or obtain the values or the probability for big X equals small x?
Looking at the graph, sir?
Very good. We're looking at the graph. So in the case of 5, it is
0.1.
0.1. In the case of 6,
0.2.
0.2. Case of 7,
0.4.
0.4. Now, we do not know the probability for both 8 and 9, but they gave us one information, a vital information. It's saying here that the probability of x equals 8 equals twice that of the probability of x equals 9. So I could put 9 to be a or any variable that you like.
Wouldn't it be 2A, sir?
Yes, and then 8 will be 2a. Then what do we do next?
We're gonna like state out the equation and make it equal to 1.
Okay. So we're gonna take our equation and let it equals to 1. So we know then that for all x, like that. So all we need to do, like what you said a while ago, we're gonna submit all of these, so that will be 0.1 plus 0.2 plus 0.3, sorry, 0.4. And then from there we have plus 2a plus a equals to 1. So that will implies then so when we add 0.4, 0.2, and 0.5, 0.1, we're gonna get 0.7. So that will be that 3a plus 0.7. And that will be equals to 1. So we're gonna have then that 3a is equals to 1 minus 0.7, which will be 0.3. So A is equals to, so A will be equals to 0.1. So if A is 0.1, then we know that that will be the probability of that is equal. So we can say then that the probability of big X equals, okay. So this will be equals to, so this will be equals to the probability of big X equals 8 will be equals to 0.2, and with the probability of big X equals 9 will be equals to
0.1.
0.1. So we have found those probability, and then they're asking us to complete the line graph. So I can complete the line graph. This is to 0.2. So this would be like a symmetrical graph. So need to go up a bit. Okay. So that would be for that one, and the other would be 0.1. It would be like ASO. Okay? So that problem is done because it said, given that complete the line graph and describe the distribution. What type of distribution is that? Looking at it, if we were to fold it along this line, this will overlap because it's both 0.1, 0.2. So what kind of distribution is that?
Exclusive, sir? Exclusive.
No, we are not asking for event. They're asking to describe the distribution. Remember when I told you that we have symmetrical distribution, then we have a positive skew distribution and a negative skew distribution.
Sir, isn't it asymmetrical, sir?
What will it be?
Asymmetrical.
Yes. Okay, gonna be a symmetrical distribution. So that would be a distribution. Let me see if I still find. Remember this what I taught you for statistical analysis 1. You can see the difference. It said a symmetrical distribution, mean, mode, median equal, or in this case. So, and then we have a positively skewed distribution, which means it has a positive kurtosis. And then this is a negatively skewed distribution or negative kurtosis and the different things that are here. So this distribution will be a symmetrical distribution. Are there any questions? Are there any questions? No, not that one. It said here that Emma plays a game in which she throws 2 dice. If she gets 2 sixes, she wins 20 pence. If she gets 1 6, she wins 10 pence. Otherwise, she wins nothing. She has to pay 5 pence to enter. Write out the probability distribution of X, the amount Emma gains in one throw. Now I will give you 3 minutes to look at it. 3 minutes to look at that question and to try to come up with the probability distribution table. Okay, let's go back to the problem. So, anybody got, let's see what if yours correspond. You check if you correspond with mine. However, I will just have this additional space up here to show. I said here that they're talking about throwing two dice, right? And they're saying if she gets 2 6s, she wins 20 pence. If she gets 1 6, she wins 10 pence. Otherwise, she wins nothing. She has to pay 5 cents to enter. So, which means then we could have 0. Remember, she have 2 chose, right? She chose 2 dice. If she get 2 6, she get 20 pence. If she get 1 and 0. So let me start from 0 here. So everybody see what if you get 2 6s, then if she get 1 6, so this is 0 6. Let me put this in. Just you don't really need that part, but that is 0 1, and you can get 2 6s. Okay. Now, if the person gets 0, he gets nothing here. It says 0 6, otherwise he wins nothing. So which means then the person would have lost 5 cents. So this would be -5 there. In order for the person to gain 1, so if he get 1 6, then he get 10 pence. So in other words, the person gains only 5 pence. And if the person get 2 of the 6s, the person gain 20 cents, which means then that the person only get a gain of 15 cents, because remember, the person need to pay 5 pence in order to go in. So this could be 15p for the pence, and this would be p for pence, and then this would be p for pence. Now, if they're throwing 2, so the probability of getting, so what the probability of getting 0 6 from the 2 die? Zero 6, which means if you look at each die, there's only 1 6. So the other 5 faces, so the probability of not getting a 6 would be 5 6 on either die. So when they are independent, so 5 6 and 5 6 will give us what? 5 6 times 5 6. So let me show you the working down here. So the probability that the person in this case lost of So for the person to get that, then he needs to have the following. Let me just show the working. Working must be shown. So each of these will be 5, 6. So this will be 5, 6. Everybody understand why? Because remember, an ordinary dice only have 6 faces and label 1, 2, 3, 4, 5, and 6. But remember, to get 0, 6, then there are 5 others. You can either get the 1, 2, 3, 4, or 5. This is 5 out of 6. And that will be from each die. So our answer there will be what? 25 over, are you hearing me?
Yes, sir.
But I see everybody is mute. 25 over 36. So that is the probability of getting nothing. Or well, nothing because you're losing your 5 cents. Now, let me go back and copy this. So to get a 5 pence, which means then with 1, 6. So the probability of getting 1, 6 on either die, it will be what? So what will it be? Students already used to know and used to be assisting. And this shouldn't be of difficulty at all. I already told you, in order for us to, your picture 2 die, you have a red and a blue, because there are 2 different die. And they want us to get 1, 6. So this can be 2 choices. 1, 6 will be 1, 6. So the other one will be 5, 6. Everybody agrees? Remember, it's only 1. Or it could be 5, 6 and 1, 6. We are dealing with 2 different die here. So we have the possibility. Remember, they are talking about getting 1, 6. The probability of getting a 6 on a die will be 1, 6. And the probability of getting what is not a 6 will be 5, 6. So to get a 6 on one die, the other die, you shouldn't get a 6 because it's only 1. Here, if you don't get a 6, then for the second one, you must have a 6. So this will become 5 over 36 and 5 over 36, which will give us, when we add them, 10 over 36. Everybody agrees? Students, I'm asking a question if you agree.
Yes, sir.
Okay.
Yes, sir.
Now, the probability of getting 15 pence, which means you must get 2 6 on either die. So the probability of getting a 6 should be 1. The probability of getting a 6 on the other die should be 1 because it's a. Give me a break here. Okay, let's continue. So this will be 1 out of 36. So which means then you could see whether you're correct. You add 25, 10, and 1. That will be 35, 36 over 36, which is 1. So in here, we're going to have 25 over 36. This could be reduced more. That will be what? 5 out of? How that will be reduced to? 2 into 10, 5. And 2 into 36. 18.
18.
And this one will be 1 out of 36. Like that. So we have completed that, the distribution. Is there any question that you would like to ask here? Because remember, they want us to write out it said here, write out the probability distribution of X, the amount Emma gains in one show. So these are her gains: 0 if she don't get a 6, -5 to lose the money that you paid. Then if you get 1 6, you have been paid 10 pence, but then you have paid 5 pence for entering the game, which means that you only gain 5 pence. Here, if you get 2 6s, you gain 20 pence, but you remember you have paid 5 pence, so that would be a 15 pence gain. Are there any questions?
Sir, can I see the questions, sir? Please. Thank you, sir.
Okay. So you see the connection now, right? You saw the connection?
Exactly, sir.
Okay. Any other questions?
No, sir. That problem was kind of tricky, though.
It's just a little bit of thought into it, because if you notice you're dealing with pence, you're dealing money here. So the random variable have to be what you have, but then in the same case here, you're paying a 5 pence to enter. It's not automatic that you get in for free. So they pay a 5 pence. So whatever you win, then you'll be subtracting 5 pence from that. That will be your gain, right?
Yes, sir.
Okay. Now what we will be doing, we're going to be looking at finding the expectation or the mean of a probability distribution function. Now, let me see if I have any question with expectation here. If not, I have to begin a new one. Oh, I'm at the wrong place anyhow. I would have never find it there. Your expectation. I got you there. I want to start off with the easier one. Since this is here already, let me just explain to you how we get these. It said a game consists of throwing tennis ball into a bucket from a given distance. The probability that William will get the tennis ball in the bucket is 0.4. A turn consists of 3 attempts. A, construct the probability distribution for X. For the discrete random variable X, the number of tennis balls that land in the bucket in a turn. And then part B, William wins a prize if at the end of his turn there are 2 or more tennis balls in the bucket. What is the probability that William does not win a prize? Now, they mentioned that William has 3 attempts, and each time the ball falls in the bucket, it says he gets the tennis ball in the bucket is 0.4. So that's been success. 0.4, and which means then not being successful will be 0.6. And I have it here. I should have had it a little bigger. Yeah. So we have the probability, I call it like A, whereby the person is being successful, and the probability of B, the person not being successful. Any questions? So now this is telling us that he have 3 attempts, so which means then that no balls could have went into the bucket. For his 3 throws, no, you can get 0. He can hit 1, or he can hit 2 of them in the bucket, or he can hit 3 of them, all 3 attempts in the bucket. So the small x takes value 0, 1, 2, 1, 3. Remember, it is 3 attempts. So for those 3 attempts, you can catch none in the bucket, or you can catch 1, or you can catch 2 or all 3. So the probability of A equals 0.4, and the probability of B equals 0.6. So everybody understood how we got these, right? Because it said here that the probability that William get the tennis ball in the bucket is 0.4. So the probability that he does not get it into the bucket will be 0.6. Because remember, probability is out of 1. So the probability of X equals 0, which means then that he misses all 3, which is 0.6 times 0.6 times 0.6. And that exact answer will give you 0.216. Now the probability that he catch 1, meaning then that that's A and 2 B's. So we could use the factorial here rather than listing now the members, because here we have 3 objects in line where 2 is alike. So this would basically be 3 times whatever. So that will be 0.4 for the A, 0.6, 0.6, and we get 0.432. And then for the 2, he will be hitting A, B. Once again, we have 3 objects in line where 2 are alike. So that will be 3, and then 0.4, and then 0.4 times 0.6, give us 0.288. And then for the last one, the probability of X equals 3, which we hit all, will be AAA, which is 0.4, 0.4, 0.4 equals 0.064. Now, if you add all of these, I want you to add all of these probabilities, you should get 1. So do that. You should get 1. Okay. Now, part B was saying, winner win a prize if at the end of his turn there are 2 or more. So 2 or more means the probability that X is greater than or equals to 2. Any questions? That will be the probability of X greater than or equals to 2, because it's saying here that William will apply if at the end of his turn there are 2 or more tennis balls in the bucket. 2 or more, greater than or equals to 2. So we go back to our table, that will be the probability of X equals 2 and the probability of X equals 3. These two, so we add those, and then our answer will be 0.352. Any questions there? Well, this was the one that we just here was looking for it, and it's right here. With the one that we did. Yeah. Okay. So when we meet again, we're gonna be looking at finding the expectation of our probability distribution. Are there any questions?
I don't think so, sir.
No, sir.
Okay. See, so I will do this question again, but it's healthy. I was looking at the wrong place. So enjoy the weekend and keep safe. Okay?
Same to you, sir. Take care. Bye.
Okay, bye. Bye, everyone.
Sir?